Hello, my name is Ann Baker and I'm the Executive Director of Development for UVA Engineering. I'm pleased to welcome who's of all ages here today to Ready to Launch the Future of Space Travel. Before we begin, I want to note that this event will be recorded. We've received a number of audience submitted questions in advance, but you may also use the Q&A function at the bottom to submit questions throughout the presentation. Our panelists will try to answer as many questions as possible after the main discussion. Without further ado, allow me to introduce our moderator for today, Dr. Kathy Thornton. Dr. Kathy Thornton is a scientist and a former NASA astronaut with more than 975 hours in space, including 21 hours of extravehicular activity. Selected by NASA in May 1984, Kathy is a veteran of 4 space flights, STS-33 in 1989, STS-49 in 1992, STS-61 in 1993, and STS-73 in 1995. In 1996, she left NASA and joined the faculty of the UVA School of Engineering and Applied Science until her retirement in 2019. She is currently on the board of the Astronaut Scholarship Foundation, the Virginia Commercial Space Flight Authority, and is the chair of the board of the Space Foundation. She is the recipient of numerous awards, including NASA Spaceflight Medals, the Explorer Club Lowell Thomas Award, the National Astronautics Association Robert J. Collier Trophy, the Freedom Foundation Freedom Spirit Award, the National Intelligence Medal of Achievement, and the University of Virginia Distinguished Alumna Award. She was also inducted into the Astronaut Hall of Fame in 2010.
Thank you, Anne. And now it's my pleasure to introduce our 2 panelists. Our first panelist is Greg Olsen. Greg is an entrepreneur, engineer, scientist who in October 2005 became the 3rd private citizen to travel to the International Space Station with Space Adventures. Greg was also the co-founder and chairman of Sensors Unlimited, Inc., a company developing optoelectronic devices such as sensitive near-infrared and shortwave infrared cameras. Currently, Greg is president of GHO Ventures in Princeton, New Jersey, where he manages his angel investments, South African winery, Montana ranch, and performs numerous speaking engagements to encourage children to consider careers in science or engineering. In 2019, he made a $25 million gift to the School of Engineering, the largest gift in the history of the school, to recruit and retain star engineering faculty, attract outstanding PhD students, and to provide the Dean of Engineering and the chair of the Department of Material Science and Engineering with additional funding to support strategic initiatives. Thank you, Greg, for being here. Our second panelist is Eric Anderson. Eric is a lifelong entrepreneur with a history of successfully introducing innovative products and services into new markets. He pursues business opportunities and research areas that inspire him, including space exploration, computable knowledge, and algorithms of thought. Eric is most well known for pioneering the development of the space tourism industry as the co-founder and chairman of Space Adventures. His team at Space Adventures has successfully arranged 8 missions to the International Space Station for privately funded individuals, launching more astronauts into space than 99% of the nations on Earth. His achievements at Space Adventures resulted in honors from Ernst & Young as an Entrepreneur of the Year regional winner, Smart CEO Magazine's CEO of the Year, and the World Economic Forum as a Young Global Leader. Eric is a magna cum laude graduate of the University of Virginia School of Engineering and Applied Science, the author of the Space Tourist Handbook, and enjoys living in Washington State with his wife and children. Welcome, Eric. Thank you for being here. Thank you, both of you, for being here with us today. We're going to talk about the future of space travel, but let's start with a bit about the history of privately funded or commercial astronauts. Greg, you had an unusual path to space. Can you tell us a little bit about how you got to space?
Sure. I was sitting in a Starbucks reading a newspaper, and I came upon an article about Space Adventures, which said that private citizens could, go up into space. And I thought, wow, this is something I have to look into. And so I looked up Space Adventures. got hold of Eric. And when I determined that, he had been to Virginia, it immediately established a bond. And, fast forward, here's a picture of me when I eventually did get into space carrying a Virginia flag. And that flag is now in the Dean of Engineering's office. But, the fact that we were both alum of Virginia really, firmed up the deal and, it established trust and everything else. And, it was a rocky path. It took about 2 years to do the whole mission, but Eric stood by me through thick and thin. And, I'm very grateful to him and Space Adventures for getting me into space.
Eric, would you like to weigh in with your perspective on that? What was it like negotiating with NASA and with Roscosmos and making all this happen?
Oh, well, sure. Well, first of all, it's great to see you guys. I mean, Kathy, you and I have known each other 25 years since I was in school there, and obviously Greg and I almost 20 years. But the negotiation with NASA, when we were talking about, or we were wondering about space tourism, right at the turn of the millennium, right as the space station was first about to be launched, the negotiation with NASA was easy because they just said no way, forget it. And it wasn't the kind of no that was maybe. So the negotiation with the Russians was a little bit different because the Russians said no, but then they said because you can't find anybody who would want to go. I said, well, why don't you let me worry about that? Could it be done? And they said, well, yeah, but then they listed all the medical, everything that made it hard that Greg talked about, but it wasn't a real no, but it was tough. But anyway, yeah, it was fun.
Yeah.
Okay. Given the 2 successful launches to the International Space Station by SpaceX in the past few months, the Demo 2 flight and the first operational flight, do you see this as a turning point in space exploration in the United States? And I'll put that out as a toss-up.
Yeah. Oh, 100%. I mean, it just opens up numerous flights, both for NASA, and I'm sure Eric can say more about this, about how the commercial business is going to go. But yeah, it's a real door opener.
Yeah, I echo Greg. I think that it was the coolest event that in terms of looking for a positive future, watching that Dragon fly with 2 people to the space station at the beginning of the summer was an amazing event. And, some might say, well, gee, we've flown these kind of rockets for 50 years. What's the big deal? But this is a reusable rocket. It's on the path for reusability. And, yeah, it's absolutely, it's a watershed.
Cool. Okay, earlier this year, NASA announced that 3 companies, SpaceX, Blue Origin, and Dynetics, are going to start developing human landers for astronauts to land on the moon beginning in 2024. What are your thoughts on this? And do you believe there's a potential for a sustainable human presence on the moon?
I'll start. I'm all for it. It's really not about technology or innovation. It's just about money. And once, the money is committed, these things are all doable because we don't need new technology to get back to the moon. We just need to take the technology that we have and, apply it, update it from 1969 to 2020 and go. So, every president since Richard Nixon, both Democrat and Republican, has said a good word about space, but they've never ponied up the dollars that you need to do these things. So now that the private sector seems to be taking over, I think we're going to get there much quicker.
So yeah, I'll just respond to the part about landing on the moon, specifically in that time frame. I mean, Greg is correct. We've done it in the 1960s. It's just about money. The problem is it's a lot of money, and it's still a lot of money. And it comes down to energy. And I think you teach this class or did at some point, the astrodynamics class. And even as hard as it is to get to orbit, you know, to go to the moon's surface and back is order of magnitude at least, you know, 10 to 50 times harder. And so every pound that makes it there requires, I don't know, 100 pounds or whatever the ridiculous number is of fuel and equipment to get there and then come back. So it's a lot more expensive until we have like orbital fuel stations and markets that can support humans on the moon other than NASA and government exploration. You know, it's going to be a while before that's commercial.
Yeah.
Okay, what do you think about NASA's proposed Gateway, the space station they want to put into lunar orbit as sort of a stepping stone to the moon, or maybe analogous to what Christchurch, New Zealand is for logistics to the South Pole? Does that help the commercial case any?
I'll start this one. I think it's a great concept. It depends on what they do and if they are wise and practical about the applications that they want to develop there. As a fuel, for example, as a fuel depot, it makes a lot of sense. But you know, thinking of space exploration, kind of in that old West or old days mantra of putting outposts along the way, I think that's a good way of thinking about it.
Do you separate out in your mind commercial development as opposed to pure exploration?
Well, to me, commercial means a sustainable, repeating market that doesn't depend on the ups and downs that Greg referred to with presidents and congresses and things like that.
Okay, does Mars fit anywhere in your vision of the future? Mars, boots on Mars?
It certainly fits in my vision. I love the you know, and dream of the day that
Sure.
that we can all go to Mars. And it's just that's even a step harder.
And remember, we have all the basic technologies that we need because we've been landing stuff on Mars for years. And we know that we can do life support for over a year with individuals. We've demonstrated that with the International Space Station. The issue is getting the resources and the commitment to go do it.
One of the things NASA needs to do to move forward is to commercialize the International Space Station, I think, is to get that off their budget and so that they can use their budget to go elsewhere. What do you think about the future of that? What do you think about the possibilities there? I noticed in both of your introductions, entrepreneur is you know, prominent in both of your intros. So what do you think? Can it be done?
Well, I remember back in the days right before the International Space Station was built and launched, there was another space station called Mir. And there was a company that tried to commercialize the Mir. And it's hard because when it's built with government money, and certainly in the ISS case, it has 16 countries involved, the operations on the ground, all that sort of stuff, it's not free even if you gave it away. It costs a lot of money to operate. So that doesn't mean I'm not saying it's not a good idea or it's not possible. I'm just saying it's harder than if you start from scratch. And the result is, I don't think that NASA could ever totally get out of it if they want it to be commercialized and exist. I think they have to support it maybe in a much smaller way and get some sort of services or other things from it to be helpful.
Yeah. Plus, it's going on 25 years now, and you know, when is it obsolete?
Yeah. With all the rise of private companies getting to low Earth orbit or planning to get to low Earth orbit, you see a future there of a commercial space station, something independent of the ISS?
I certainly do. I mean, guys like Bob Bigelow have been around for a long time working on things like expandable, inflatable structures. You know, a space station could be the size of an RV. It doesn't have to be the size of a football field. Right. It could be human tended, for example, where there's not always a person there. It's just a place you visit. I think that's a lot lower risk path, and I would expect to see some of that. Yeah.
Okay, we have, many international partners on the International Space Station. We've had astronauts from other countries up there. We've worked with the Russians for a long time. What do you think about our prospects of working with China in the future?
Boy, we should have Leroy Chow here now.
Well, Greg, tell maybe you want to mention when we went to China together right after their first launch and after you flew,
Oh yeah, with Mr. Yang, he wasn't allowed to speak with me. And I was told not to go over and speak to him. So, now that was 15 years ago, but yeah, there are going to be a lot of issues of that sort coming up, trust issues. It's funny, even though politically we're at loggerheads with Russia now, politically that is, in space, I felt that there was complete trust with both sides.
Interesting. There's legislation that says that is the reason why you couldn't talk to the Chinese.
Yes.
And NASA cannot do that. Yeah. In this global pandemic, what are the implications does this have for space exploration? Is this an argument for moving beyond this planet or not?
Well, humans can carry viruses to other planets as well, since it is transmitted by humans primarily. I think it affects space like it affects everything else, which is primarily economic. It's pressing everybody. And my guess is, even though SpaceX seems to be going gangbusters with all their launches, I think if the overall economy slows down, overall space travel will probably too.
I can give two quick perspectives on that. When it first started, when we were in sort of March, April, May, it wasn't the time to be we have some open flight opportunities that we're marketing and sort of working to fill right now, and it wasn't the right time to be talking to people about that. That's for sure. On the other side, I think that this pandemic, as in every other part of life, has made clear the importance of good quality connectivity and broadband and all this sort of stuff for the future, period, and accelerated it. And so, for example, SpaceX has Starlink, and there are other projects too. Those are going to be helped out because it's just critical that people who live in remote areas or who aren't on a fiber line can get connectivity to be able to connect to Zoom and everything else.
Yeah. I have a ranch out in Montana that doesn't have a fiber going out to it. And we've applied for the Starlink system, and we're really hoping to be one of the first recipients of the service.
That would be nice. That does open up a lot of commercial opportunities for people who are beyond our current internet capabilities. Okay, if you I'm looking at some of these questions that came in before we started. What markets do you see in the commercial space industry unlocking in the next 5 to 10 years? What kind of potential market do you see out there that you're going to go for?
Well, the first one I would look to is Eric for that, and taking people up into space.
So we've already, I mean, Greg and his flight and the others who've flown, in the first part of the space station's life, have shown that there's a market, and people definitely want to go to space. A lot of people want to go. It is still very, very expensive, but the market's there. And so to have a real industry, the price needs to come down quite a bit, of course. But I think there are other things that are starting to happen too. Manufacturing in space, 3D printing, using the microgravity environment. Obviously, things like mapping and GPS and sensors and all that sort of stuff. Space it's everything but Earth. It's a useful place to go, and we're figuring out more and more uses, I think.
Yeah, the Starlink is a great example. I mean, I think they have almost 1,000 satellites already in low Earth orbit. And there are going to be many more.
Okay. If you think about some of the objectives for space exploration in the next few decades, like deep space telescopes and robotic exploration, and human space flight and settlements, what innovations do you think will be necessary to make those breakthroughs? What do you see in the future that we have to fix or invent before we can do those things?
I think most of the stuff is here already. About 10 years ago, Eric and I visited SpaceX out in California. And I remember Elon Musk's bragging about the fact that almost everything he had was off the shelf. And he said that was one of the keys to making this an ongoing successful business in lowering the price. So, I think it's less about new inventions that we need, and it's more about just getting the logistics and the commitment.
Yeah, I think there's a lot that we need to learn in terms of biomedical still. I mean, we've obviously had 40 years of experience, 50 years of experience in individuals flying to space, but like you, Kathy, most of the people who've flown have been professional astronauts. They've been very, very healthy. One of the nuances of space tourism, and we've only had 8 missions so far in the industry, was that not everybody was a fighter pilot medically. And so, Greg, I'm sure could tell you more about that. But the point is that I think there's going to be a lot of things that we learn about how the average person can go to space and what can keep them healthy.
I've always thought I was pretty average.
No, you're not. You're not.
Okay, here's a question from a participant or an audience. How do we get more students interested in space and its related industries?
I think we're doing it right now by having events like this. Lots of people are curious, what's it like to go to space? What did you do? And I think just by getting the word out, more and more people will become interested in it.
Okay.
Yeah, I think that what the sort of thing that gets somebody really interested and sort of that spark often comes with a personal touch. Whether it's somebody they know that's affected or something that they're interested in. And, as more and more people start to go and somebody hears about it, or that somebody from their hometown or whatever, that really can be a huge spark for kids. It can be
Sure.
that sort of thing, I think, really helps.
Yeah.
Okay. This may be somewhat related, but where are the current geographic hotbeds for the space industry? I think that means where the centers of the space industry. Used to be just Florida and California, but
Texas,
there's new ones.
Texas big, yeah.
Yeah, Texas, Florida, California,
Virginia.
Virginia, all the places with lots of electoral college votes.
Yeah.
Okay. In your opinion, what's the most novel idea or concept in space travel in the last decade?
Boy.
That's a stumper, because
Yeah.
actually most of what's been done has not been a new idea. I think the practical applied application of everything that's been learned over the years by SpaceX and others, that are trying to follow SpaceX is certainly super impressive. But the rocket equation and the physics have been around for a long time. So.
Okay.
There are things that have been tried. You mentioned rail guns earlier. This guy, trying to do microwaves to launch rockets. There's lots of ideas out there and lots of tinkering. In terms of, what's up in space now is pretty much existing technology. I agree with Eric.
What about the CubeSats and even subdivided CubeSats up there? Is that?
But sure going to bring the cost down.
Yeah.
One of the interesting things about the miniaturization of satellite technology is that it's not been that helpful increasing the size of the launch market, in the sense that what used to be a massive satellite could now be much smaller, which means that the number of required pounds that go to orbit is less, even if there's, or the same, even if there's a greater number of satellites. So, you know, that one impact that people don't often think of about CubeSats is it's probably reduced the number of launches required for the satellite industry.
Yeah, that's a good point.
What about satellite servicing? That will further reduce the need for launches, I would think.
I think that's a great concept, and that's something that you know, we'll hopefully start to see. I've heard about that for a long time too, and you know, that's an opportunity that I don't think yet has been realized.
Yeah, the figure I think of $10,000 a pound is probably still in the ballpark now. Hopefully that's going to come down, but you know, to get something going at 17,000 miles an hour ain't cheap.
That is a fact.
That's right.
Okay, here's another one. Eric spoke to the incredible cost of power. Can he offer insights towards what he believes the next generation of power sources for space travel will be? Nuclear, thermal propulsion, others?
Oh, geez. Well, there's all of those things that you mentioned are things that people have talked about for a long time. A lot of people don't realize there was a nuclear powered rocket engine, 500,000 pounds thrust, built in the 1970s. NERVA, nuclear thermal, and then electric things like ion thrusters, all that kind of stuff. They've been built, and they're low thrust. I don't have the answer. I guess it's like energy on Earth, whatever we can make that works and safe.
Yeah, I would agree.
Some decisions are driven more by politics than by technology as well. Let's see. Can you talk a bit more about the physical demands of going to space? How did Greg prepare for his flight?
Sure. Well, you don't have to be an Olympic athlete to go to space, but you have to be in reasonable shape. You know, I had a roughly 6 months of training in Moscow before I launched, and it was like being a combination college student and on a military base. Life was kind of Spartan. You get up in the morning, do some running, go have breakfast, classes 9 to 4, more physical training 4 to 6, dinner, homework, get up and do it again. So it really is like being a student. And I really enjoyed that part of it, the training. Hardest part for me was trying to learn to speak Russian, because I've never been good at languages, and boy, when you're 60 years old trying to learn that, it was tough. But you know, I was in the best shape I was since high school, so that was a big plus for me. It's interesting how NASA and the Russians differ on how you prepare for motion sickness. The Russians believe you can kind of train into it. And we had all of these exercises like being on a seesaw and having the blood run into your head and into your legs. They put us in a barber chair and spin us around and make us, you know, nod our head, yaw, roll, and pitch. And the belief was the more you did this, the more resistant you become to motion sickness. NASA sort of, tries to use medication, I believe, rather than the preparation. But, the training worked because, I did well up there. I loved being weightless. After I came back, I did a couple of flights on Eric's zero-G flights. And I've taken my family and friends up, and, I just love being weightless.
That is fun. I agree. As the mother of a UVA fourth-year mechanical engineer who is interested in entrepreneurial endeavors, would you share your path to starting up space adventures, Eric?
Okay, well,
it started at UVA.
Yes, it started because I wanted to be an astronaut, and that's actually why you and I met the first time, Kathy. And then I realized that probably wasn't going to happen because my eyesight was not very good. And there's a whole number of steps in between that. There's actually a talk I gave a year and a half ago called Windows of Opportunity. It's on the Space Adventures website that kind of goes into this. But the sum result is that we just had a chance, and we took the chance when we had it, and there was no guarantee that we would be able to be successful, to find customers, to get a seat on a rocket. But once you do it once, then you build momentum. And you know, I'll just leave you with this: for the fourth year mechanical engineer, the number one characteristic you need to be an entrepreneur is grit. You just it doesn't matter, you know, what your test scores are. It doesn't, none of that matters. What matters is how relentless you are. That's what matters.
100% agree. You know, I've started and sold 2 companies, and now I do investing in others. And that's the one thing, the successful companies I've had, it's his CEO has always been terribly driven, doesn't take no for an answer, and gets knocked down and gets up and gets knocked down again and keeps getting up. You'll kind of see it with Eric. You know, if he gets a no, it's, let's see, I'm going to have to use another approach. But it's never, you never accept no.
So Eric, how did you get past NASA just say no? Because I know it was a pretty vehement no. I was in the astronaut office at the time.
That was tough. I remember, you know, I was like 26, 27 years old, and there was a article, there was a whole Newsweek thing where Dan Golden, who was the administrator at the time, was, you know, really not positive. And I was in it. I was like, oh my God, this is terrible. We've since become friends, by the way, Dan, you know, much long after, been friends for a while. But the short answer is we didn't get past NASA. The Russians did. And once we got them on board, then they weren't going to let anybody tell them who they could fly on their rocket. So, so we just sort of stood in the background while that went on.
Yeah. I think I was the 3rd private citizen to fly in space. And by the Dennis Tito was a real pioneer, and he got beat up by a lot of that stuff. And by the time I rolled around, I was the 3rd, while NASA wasn't, you know, having cocktail parties in my honor. They had sort of resigned. I could tell they were sort of resigned to this. And I met a number of the folks, and they saw I wasn't a whack job, and Mike just, you know, towed the line. I think I was sort of accepted. The good thing, when I went over to Moscow and I met the astronauts, the NASA astronauts who were training in Moscow, you know, we struck up a bond because amongst other things, I had this winery in South Africa, and the Georgian rot that they were drinking locally, I had some half decent wine. So I immediately got in with the NASA crowd, and you know, they were all very supportive and
Good, I'm glad to hear that. What do you think about Stephen Hawking saying, if we're not off the planet in 100 years, we'll be too late?
When did he say that?
I'm just reading the question.
Probably about
How much of it's gone, right? How much do we have left?
Well, you know.
Well, yeah, I would say too late for what? I mean, you know, does he mean, and I've read almost all of his books. I think he's amazing, and God bless him. It's just, you know, does it mean that there's going to be big problems in 100 years if we don't fix the ones we have now? Yeah. But, you know, will humanity survive? Yeah, I think so. Yeah, we'll be all right. But I think it's good to get off the planet anyway, because it's fun and it's, you know, it's more knowledge and more resources and all that stuff. So, yeah.
Definitely.
Okay. Greg, this is for you. What did weightlessness feel like?
Magic. That's the only word I can use to describe it. And you know, during your training, you do 0G flights where you get to be weightless for about 30 seconds. But you're actually at equilibrium, being weightless for for the foreseeable future. It's just magic. And I just reveled in it. You know, again, fortunately, I didn't have any of the, you know, medical issues that sometimes go along with weightlessness. So, you know, I just adapted to it right away. And I mean, whenever I had the chance, I would just go back and forth in this space station. And one of my favorite things was, you know, doing 90-degree turns and noticing how my brain would say, okay, this is up, and now up is here, and then up is here. And it's amazing how your brain allows that all to happen. I just enjoyed it.
Okay, I don't know how comfortable you are thinking of policy and space law, but NASA is sort of rewritten the Outer Space Treaty, which governed a cooperative agreement for our collective behavior in space, and now they're updating it for potential occupation of the, you know, permanent presence on the moon and extracting resources and all that. What do you think is a model for self-governance in that environment off of this planet?
Maybe, I don't know. You know, it seems to be reasonable cooperation amongst nations in Antarctica. Issues always come up, but that's maybe a model to follow.
Well, I have a little bit of experience in this because I spent a lot of time going in and out of the offices of various congressmen, congresspeople, and senators, and the White House back in 2013, 14, 15, before the ultimate passage of the first asteroid mining law that was signed by President Obama maybe 4 or 5 years ago. And basically, throughout that entire experience, I was the founder of a company called Planetary Resources, also for asteroid mining, which we were a little early on. But anyway, you learn a lot about history, and the fact is that there definitely needs to be private rights. They have to be done responsibly, but if there's no private rights or ability to get private rights, people won't invest, and governments will just fight over it. So that's a really complicated question, but it's one that needs to be thought through and answered well.
Okay, you mentioned different markets that might emerge from spaceflight over the next 5 to 10 years. Do you think resource extraction might be on the horizon? And if not, in the 5 to 10 year window, then how far out? What will the challenges be in bringing materials back from space in mass?
I think Eric is the one to answer this one.
Okay, well, back in 2010-ish, Peter Diamandis and I co-founded Planetary Resources. And the reason that we did was because, well, we've been working on space tourism for some time, and thought, you know, what else is out there on the horizon, and so I started looking into it, and I found out that some of these asteroids are very, very rich in platinum group metals, and so I calculated using my UVA Engineering, aerospace engineering background, that one platinum asteroid that was like the size of a small room was worth a few $1 billion. And I thought, it can't cost that much to go bring that thing back. Now that actually doesn't work because it does cost a lot, and the platinum market isn't that big, and et cetera, et cetera. But the point is that there's a lot of valuable stuff out there. But it turns out the most valuable thing in space is water right now. Mm-hmm. And so where we ended with Planetary Resources was to try to build refueling stations that would have liquid oxygen, liquid hydrogen in orbit or in deep space at particular points. But the reason I say we were early, and I wasn't joking about that, is because there's not enough people out there who need fuel in space yet. And it's sort of like the market, you know, the chicken and egg problem. So it's a hugely important part of the future, but I can't tell you when it will happen. Mm-hmm. And how long that'll be, because it sort of depends on a lot of other factors, particularly how many customers there are for
Yeah, if we go back to space tourism for a bit, we're getting the capability now to launch privately funded citizens into space. The only destination is the space station at this moment, but I know that people have thought about building destinations in space. Bigelow is one, and I think Axiom Aerospace has got that in their business plan.
Yeah.
What do you think about that? Is that going to be successful? Is it going to be, are we ready for that now? It has the, do we need to drive down the launch cost more to make that a possibility? What do you think?
Well, yeah, to get a large business, sure, you're going to have to drive down the cost, but there are other things like a loop around the moon, even without landing. That's something that's possible now, and maybe Eric wants to talk a little bit more about that as well.
Yeah, I think Greg's intuition, and obviously he's been, so he knows about the value of the experience and everything, are correct. And in order to get quite a bit bigger of a business, like billions of dollars a year business, which of course is still small on the world stage, I think the price has to come down to less than 10 million, say, per seat, which is still very expensive, of course. But while we're waiting for the price to come down, there are a lot of unique things that we could do. Smaller little space stations that you visit, stations in different orbits, stations in higher orbits, spacewalks, circumlunar flights, deep space gateway, et cetera, et cetera, et cetera. And so what Space Adventures has done is tried to be creative and tried to figure out the new kinds of unique and, really just interesting experiences that the very, very early adopters might be interested in.
Yeah.
Okay. Here's a question. I teach a first-year seminar at the University of Richmond called The Space Race, mostly about Sputnik Apollo era. My students and I spent a good deal of time studying public disenchantment with human space travel after the triumphant Apollo 11 landing. How do we retain public support for space travel today after we have achieved some of the currently stated goals of NASA?
Well, I went through that era. I was in 7th grade when Sputnik launched, and I remember looking up in the sky and seeing this thing moving and listening to the beeps from it. And then when the moon race came on, I mean, it was front page all the time. This development, that development. It wasn't just, the landing, but during the 60s, everybody was into space. And I would say the vast majority of people supported it. And even though we had a war going on in Vietnam at the same time, we were still spending almost 5% of the entire US budget to get to the moon. Now, last I remember, the figure now is about 0.7% of the US budget. So, we had the financial commitment back then, but we also had the excitement. I mean, people were really up for this dream. Let's go to the moon. And that's what I think we need if we want to get a government space effort going again.
Yeah, I'm going to weigh in on this. So I would say, look, human psychology is such that people start to take things for granted pretty quickly.
Yeah.
And I think that, and I'm not suggesting that there be a lot of drama, but drama and competition and things that evoke emotion in space, that's what gets people interested and maintains interest. I think that it's unfortunate. I'm about to say something that maybe NASA wouldn't love, but NASA. One of the reasons SpaceX has done so well in hiring people is because Elon is willing to go out there and put a vision of landing on Mars in some short number of ridiculous years, and people kind of believe that it's possible when he says it. Maybe they know he's a little bit optimistic, but NASA, and it's not even NASA's fault, but they have vacillated so much and kind of made space boring. At least they did for the 90s, and early parts of this millennium. So it's got to be exciting. And it's not just the rockets, it's the idea. What are we doing? What's new? Who are we competing with? Et cetera, et cetera, et cetera.
Yeah.
Okay, speaking of Elon wanting to get on Mars in his lifetime, what do you think that timeline is? Will I see people walk on Mars? By the way, my Social Security calculator says I have 20 more years, so will I see it?
It'll certainly happen in 20 years.
People walking on Mars in 20 years?
Oh yeah. I mean, if you, I think the latest thing that Elon said was that the first mission would land in 4 years or something, which I think is a bit optimistic, but
10 years, certainly. Yeah.
I'd say around 10 years. And it's okay to be optimistic too. I think that's kind of what drives us. It's like the I forget the name of it, but it's like the placebo effect, the Pygmalion effect. You have to kind of believe it, and that helps make it happen.
Yeah.
I'm all for it. Okay, here's a question that came in. How long was Greg on the space station, and what did you do when you were there?
Okay, I was on the space station for 8 days. It took me 2 days to get there, a little over 2 days, because we had to do 34 orbits before we docked. Now they can do it in as little as 2 orbits because they have much better guidance systems. But back then it was a 2-day ordeal. So I was on for 8 days. I did a lot of looking out the window, taking pictures and videos. Now, I did have a scientific program. I actually had a very ambitious program, including I brought up a spectrometer that was built by the astronomy department at UVA. And we're going to hook that up with my Sensors Unlimited infrared camera. But for long, complicated bureaucratic reasons, I wasn't able to bring my camera up. So therefore, the spectrometer is still sitting up in the space station, waiting for somebody to use it. But I did some medical experiments. They did these exercises trying to make me sick, and I seem to be somewhat resistant to motion sickness. I took bacteria samples, did a telephone call once a day down to my family, but mostly just enjoyed the whole experience. I did have a fair amount of free time, and I was the first one up, and I would just go to that window and look out and, look down on that big blue sphere or that black sphere with a little light shining up.
Awesome. Okay, we are getting toward the end of the hour. We have one more question. This one's for Greg. What is that thing behind you, and can you talk about it?
Well, you mean, that's my spacesuit, if you're talking about the one
Tell us about it.
over on this side. Yes. Yeah. And that's the actual spacesuit that I wore on my flight. Eric was kind enough to negotiate to get that as part of my deal. It was actually made by hand by 3 Russian women, one of whom claimed to have done Yuri Gagarin's spacesuit. And judging by her age, it was possible. But you're fitted for these things just like a bride for a wedding. You go in, the first thing they did was put me in a bathtub in a bathing suit, and they filled it up with foam, just like you do a dental impression. So they got a body shape, made the suit, and then the fingers were too short, so they had to, cut the fingers off, put new fingers on, and after 3 fittings, they got it. So, and again, thanks to Eric, it's sitting here in my office in Princeton now.
It's your trophy from the training. and the training overall, by the way, would you say the training was fun, or was it all hard?
No, it was a lot of fun.
Okay.
It was hard, but it was fun again.
That's good. Okay.
I enjoyed it.
Okay, thank you guys.
Thank you.
Well, unfortunately, we are out of time, but what a fantastic discussion that we've been able to listen to today. I want to thank Greg, Eric, and Kathy for sharing their time and their expertise with all of us. And I want to thank everyone in the audience for joining us and submitting such great questions for our panelists. I hope everyone has a wonderful rest of their day. This concludes the webinar.
You bet.